All right, and so we have a couple questions that we need to answer first. And those questions are, what is a term and what is a polynomial? So what is a term? So a term in math is just any number or variable that, or a product of numbers and variables that's by itself, right?
Right.
A term can be almost anything, but it's what makes up part of a mathematical expression. So a term is any variable, number, or product of numbers of a number and variable that is by itself. All right, so that is a term. Okay, zoom out. A variable, number, or product of a number and variable that is by itself is considered a term. Okay, and so we'll look at examples of terms in just a second, but I just wanted to make sure that we have that definition of what a term is. All right, and then what is a polynomial? All right, so let's break down the word. What does poly mean? What do we think poly means?
3.
So poly actually just means many.
Many, right? Many.
Poly is just many. And what is nomial? What does that look like? Nomial. So
Numbers.
numbers maybe. Okay, so actually it's nomial is more like name, right? So so when we have polynomial, right? A nomial is referring to a number or a name, right? And when it's many, so a polynomial means it has just many numbers or many terms.
Okay.
A polynomial just means that it has, so it's an expression with many terms. Okay, so it's a polynomial. Okay, technically, anything over 3 terms is considered a polynomial.
That's what I knew. Was something about a 3.
Yeah, but after we get to 3 terms, we stop having special names and we just call them a polynomial.
Okay.
So anything after 3 terms is really a polynomial. Okay. All right, so that's pretty much what we need to have just as our basic understanding of polynomials, a term, and what a polynomial is. We have that. Okay, so now let's go a little bit deeper and talk about what a term can be. So a term can be any of these examples that we have here, right? It could be 2, it could be x, it could be 3y, or 8x squared z to the 4th power, right? So what do we call a term that is just like the number 2? What would we call that?
Say it again.
What do we call this? What is this, the number 2? What do we have?
A number.
Just a number, right? It's just a number by itself. So a term can be a number by itself, right? All right. And then what do we have here when we have x?
A variable.
Good. It's a variable by itself. And then what do we have down here with 3y or 8x squared z to the 4th power? What is that?
An expression.
So we call it, in the definition that we just wrote, we called it a product of
A product, a number or variable, okay. X.
So a product of a number and variable.
I didn't even like that.
So that's what a term can be. So a term can be a number by itself, it can be a variable by itself, or it can be a product of a number and variable by itself. Okay? So that's what we have. So this is 3y, that's considered a term, right? X is considered a term, 2 is considered a term. Okay, when we combine those things together is when we get polynomials, right? Because then we have 2 plus x. This plus means that we're now putting 2 terms together, right? And we can't combine them any other way. We can't make them 2x because we're not multiplying them, right? That would make them one term. But we have 2, which is one term, it's a number, and then x is another term. So we have 2 plus x. And that's an example of a polynomial because we have 2 separate things, right? And then so here we have another example where we have 5a minus 6ab plus 3b to the 4th power. Even though they have a's and b's, they don't have the same combination of a's and b's, so they are separate terms, right? We can only combine them when the terms are the same, okay? And then we have 4x cubed plus 6x squared minus x minus 7, right? Again, another example of a polynomial. So this first one, 2 plus x, is actually what we would call a binomial, right? Because it has 2 terms, right? 2 terms means it's a binomial. Bi meaning 2. This next one has 3 terms, so it is a trinomial. And this next one has 4 terms. So this one is actually the only one that's officially called a polynomial. Because when it's bigger than 3 terms, we start calling them polynomials. They don't have any special names after that. They're all just polynomials after 3 terms. Okay? So those are our examples of polynomials. All right. So let's talk about what a polynomial can have and what it cannot have. So a polynomial can have a constant, which is just a number, right? It can have a variable, right? And it can have exponents. A polynomial can have addition, it can have subtraction, and it could have multiplication, right? A polynomial can also have division by a number, right? So when we have 2 as the divisor, that's okay in a polynomial. What a polynomial cannot have is division by a variable. So when we have a variable in the divisor position, it is no longer a polynomial, all right? Because that's too many obstacles, too many variables could happen when we have that situation, so it's no longer considered a polynomial. When we have negative exponents, it is no longer a polynomial. When we have decimal exponents, it's no longer a polynomial. And then we have just like terms that never end. They just keep going. They just keep adding and adding and adding and adding. No, that's not a polynomial, right? A polynomial is very defined. It has a certain number of terms. It can be 6 or 7, but it can't just keep going till it never ends. All right, so it has to have a set number of terms. So this is what a polynomial can have and what it cannot have. Just more information for you all as we move forward, kind of like figuring out what those things look like. All right, so let's name polynomials. We already did earlier, right? Like I was saying before, anything more than 3 terms is considered an official polynomial. If it only has 1 term, it is called a monomial. All right, if it has 2 terms, it is a binomial. Bi means 2. And if it has 3 terms, it is a trinomial.
Oh, did I skip
Our
one?
examples there. All right, 1 term monomial, 2 terms binomial, and 3 terms trinomial. Right? That's how we get the names for a lot of things, is by using those prefixes bi, tri, and mono. Monopoly, of course, is about having one company in charge of many things, right? Bicycle is a vehicle with 2 wheels, right? A tricycle is a vehicle with 3 wheels, right? So we definitely have seen these prefixes before, but it's good to have like better relationship with them to understand what's really going on, right? Monomial is 1 term. That's our example here, 6x, 2 terms, 3x squared minus 7x, and then 3 terms, 5x cubed plus 4x squared plus 1. And you'll notice here that they are separate terms, even though they have the same variable, because once you have x squared, yeah, that exponent makes it a different term. Exactly. Right? And so that's a whole different term. The other thing here too is that we not only name our polynomials by the number of terms, we also name them by degree. And so that's what we're going to talk about now, is the degree of polynomials. So polynomials are often classified based on their degree. If there's only one variable involved, the degree of the polynomial is the largest exponent of that variable. Okay, whoa, that's a lot. So what that really means is that you have to try to put them in order based on the exponent. So if they're not already written in order, you have to write it in order so you can decide which one is the largest exponent. So as we can see here, we have 5x to the 4th plus 9x to the 3rd plus x squared minus 6x plus 2. So this polynomial, this example, has a degree of 4 because the largest exponent is 4. Okay, so that's the degree of this exponent. It's based on the fact that the largest exponent is 4, right? So then it will be named according to that exponent. So again, how many terms does this exponent have? This polynomial have? It has 1, 2, 3, 4, 5. So it's just a polynomial, right? But what kind of polynomial? It's going to be a 4th degree polynomial, or what we call a quartic polynomial, because it has the 4th exponent. And you don't have to write that down right now because there is going to be a space later down in the notes where we're going to write that down. But because it's the 4th degree, we're going to name it a polynomial, of course, because of the number of terms that it has. But then what kind of polynomial is it? Well, the kind of polynomial it is a quartic polynomial because of the 4th power. Right? So that's how we name them. We name a polynomial based on the number of terms first, right? And then we have to have a descriptor of what kind of polynomial. So we need to know the degree that it is. So when we're thinking about it, we have to think about it as like we have a car, right? All of these polynomials are cars. And then we have to figure out what color the car is, right? And then that's the descriptor that goes before it. So the exponent is the color, right? And then the kind of car is the number of terms that it has, okay? All right, let's look at another example. If there are several variables in the polynomial, you need to look at each term individually and add the exponents of the variables together to find the degree of each term. So the highest degree you find is the degree of the whole polynomial. So in this case, which we will rarely see cases like this, but sometimes this happens, where we have 2 variables and they both have exponents, right? So we just have to add those exponents together. So we have 2 and 4, which would be 6, and then 3 and 5 together, which would be 8. So the degree of this polynomial is 8 because we've added those 2 exponents together, okay? So this is just another example of how that would work. We're normally only going to be working with 1 variable, but in the case where there are 2 variables, you do have to add them together. And you see how this is written right now with the 2x cubed coming second? That would never happen. You always want to make sure that you write the highest exponent first, right? That's called standard form. All right, standard form is putting the highest exponent first. We have some definitions for that as well. Okay. Any questions for me so far? We're going to go over our definitions next, our vocabulary. I'm going to go do our vocabulary, then we're going to name them, and then we're going to add and subtract them. Okay, let's look at the vocabulary. All right, so we have 4 more words we need to define, because we already defined, of course, term, we already defined polynomial, right? And we already figured out the different kinds of polynomials, binomial, trinomial, or monomial. So now we need to make sure we define these other words as well. So degree, what does the degree refer to? We just talked about it. So the degree is the largest what found in the polynomial?
Exponent.
Good. The degree is the largest exponent found in the polynomial. Okay, so that's what the degree is. And then standard form is arranging the order from the blank to the blank exponent.
From the highest.
Mm-hmm.
The
Good.
highest exponent to the
Good, from the largest or the highest, good. The largest exponent to the smallest. Very good. All right. And so the leading coefficient we haven't talked about yet, but the leading coefficient is the coefficient of the highest degree term.
Oh, highest degree.
Term in the polynomial. Okay. So the coefficient of the highest degree term in the polynomial is called the leading coefficient. So if we go back up to our examples really quickly, so we know that this term has the highest degree, right?
Mm-hmm.
Coefficient in front of that, this term is 2. So that's the leading coefficient, it would be 2. Go back to the previous example, we know that this term has the largest exponent, so the leading coefficient here would be 5.
Okay.
Yeah, you're just looking at the number in front of that term. That's all you're looking for the leading coefficient. Okay, and then last is the constant. So the constant is a term that has no blank. It's just a number. So it has no what?
Variable.
Very good. That's what a constant is. Okay, so a constant is a term that has no variable. All right. Okay, so then what now with this vocabulary, it should be easier for us to kind of work through some problems to figure out the different kinds of polynomials we have. So let's try it. So we have some examples here. And I'm going to rearrange my notes a little bit so it's all on the same page, but okay. We have some polynomials, and I've done the first one already. We're going to do the other ones together, but we have to name the degree of the polynomial. We have to put it in standard form, which means putting the highest one first, tell what the leading coefficient is, name the constant, and then name what kind of polynomial we have, right? Mono, bi, tri, or of course, it could just be a polynomial. Okay, so this first one, of course, is 4 minus x plus 2x cubed, so that's why it's a third degree, because it has 3 as the highest exponent, right?
Mm-hmm.
The 2x to the third power first, then we put the x next, and the constant is always last. The leading coefficient is this 2 in front of the x cubed, and our constant, of course, is 4. Oops. Do that. And we have 3 terms, so it is a trinomial. All right, what about this one? What about this polynomial? What is the highest degree that we have in this polynomial? What's the highest exponent that we have?
6.
Perfect. So that's the degree. Okay, so when we put it in standard form, that means that term with the 6 has to come first, right? So I have to put negative 3x
3x
to the 6th, right? Okay. Now what? What comes next?
4x squared. I mean,
4x cubed, right? But good, yes. That's right. 4x cubed. All right, now what? What's next?
plus 2.
We're missing this one.
Oh, plus x squared.
Good.
Plus x squared.
And then plus 2. Perfect. Okay, so now we've put it in standard form. We just rearranged it so that the highest exponent is first, then the next highest, then the next highest, and then finally the constant. We always end with the constant, right? Okay, so what's our leading coefficient?
Leading coefficient -3.
Perfect. And what's our constant?
+2.
Perfect. And so what kind of polynomial do we have?
A quad.
So we don't name the quad, so it's just called a polynomial.
Oh, polynomial.
Right? Good.
So would that
Good.
be the fourth term?
Sorry? What was the question?
So would that be the fourth term? When it has the 4?
When it has 4 terms, remember we don't name it anything except polynomial.
Polynomial, okay.
Right? Anything 4 and higher, we just name polynomial.
Okay.
Yeah, we only name the first 3. When it comes to 4 and higher, we just say polynomial. Okay, so what about this next one? We have 3 minus 5x. What's the degree? What's the highest exponent that we have?
-5x.
Good. So what's the exponent there?
There's no exponent.
There is an exponent. There's always an exponent, right? What's that exponent that's there? On that?
Oh, the x.
So what is the exponent on the x though?
5x.
It's 1.
Oh, that's because x is always 1. X is always
Right?
1.
Good. So the exponent there is 1.
1.
Okay, good. So as you were saying, yes, of course, the first thing we're going to put is a -5x, right? And then we're just going to put plus 3. That's how we write that in standard form. So what's my leading coefficient?
-5.
-5. Perfect. What's my constant?
Positive, just 3.
Yep, of course. Yep, and you can say +3. Good. So then how many terms do I have? I have 2.
Binomial.
Binomial. Perfect. That's it. All right. So anytime we have just a variable without an exponent, the degree is
1.
Okay.
Yeah.
All right. So what about here? What do we have? What's our degree? With the -4x.
4.
What's the degree?
No. X, 1 again.
There it is. Good. Don't worry. You're going to get used to all the vocabulary. It's going to get more and more comfortable. Okay. So, of course, there's only one term, so it's already in standard form. It's -4x. We can't change it.
Right.
The only thing. So what is the coefficient?
-4.
Perfect. What's our constant?
The constant is 1.
We don't have a constant. There is no.
Oh, yeah, it's no.
So it's 0.
Okay.
Okay. There is. So if there's no number there without a variable, then the constant is 0.
0. Okay.
And how many terms do we have?
A polynomial.
It's one.
No, mononomial.
Monomial.
Monomial.
Monomial. Good. All right. So that's it. That was that one. Okay? Let's try this next one. So we have 14. So there's no variable. So what's the degree? If we don't have a variable, what's the degree?
1.
There's no variable, so our degree is actually 0.
0.
Okay? There's no degree, so there's no variable. There's no variable, so there's no degree. We
Okay.
have a variable to have a degree. So when there's
Okay.
no variable, there's no degree. Okay, we only have one term, so standard form is just 14. Okay, we don't have a variable, so again, we don't have a leading coefficient, so it's 0.
Okay. 0.
All right, and so our constant is what?
0.
Nope, we have a constant now.
Oh, 14 then.
That's it, exactly, yeah. And again, we only have one term, and what's one term called?
Monomial.
That's it, monomial, that's it.
Monomial, okay.
Monomial, yep. All right, let's try this one. A little bit more difficult. There's more terms here. So what is our highest exponent that we see here?
4.
Good, perfect. All right, so now we have to put it in order. So of course, we're going to start with the one that has the 4. So I'll put that in. What's next?
Negative.
Negative x to the 4th. Now what's next?
Positive 4x.
That's not next. What's our next exponent after 4? If we're counting.
Oh, negative 8.
We're looking for exponents. Exponents.
Oh, exponents.
What's the next biggest
positive, positive 3x cubed.
Perfect. Yep. Okay, now which one is next?
X cubed squared.
Good. X squared. Oh, I'll fix that. Okay. What's next?
Positive 4x.
Perfect. And then we're going to end with
Negative 8.
minus 8. Perfect. Okay. All right. So what is our leading coefficient?
Negative x. Negative x. 4.
So what's our leading number then? So it's negative.
Negative 4.
Negative.
Oh, negative 8.
Negative 1.
Oh yeah. Oh,
Right.
because the x is 1.
Exactly. Good. Okay. What is our constant?
Negative x4.
Our constant is always at the end of our.
Oh, negative 8.
Very good. Okay. And so we have 1, 2, 3, 4, 5 terms. So what do we call that?
Just a polynomial.
Perfect. All right. So that's what that one is going to look like. Good. All right. Our last one. What is the highest exponent we have here?
Negative 5x.
The highest exponent we see? Exponent.
Oh no, 2x squared.
So 2 is our degree, okay? And we're going to start with, so 2x squared, right? What's next?
Plus negative 5x.
Perfect.
Plus, positive 1.
Plus 1, perfect, that's it, good. So what is our leading coefficient?
2x squared.
Nope, just 2. We just want the number, right?
Oh, just 2.
The number in
Yes,
front is just 2. Good. And what is our constant? What's our number at the back?
Positive 1.
Perfect. And we have 3 terms, so what do we call that?
trinomial.
Perfect. All right. Yeah, so this was it's a good little challenge to like figure out what all those terms mean. We've now used those terms that we just defined, okay? So use this table. It's gonna be very helpful to you as you kind of think about all those little terms and everything they're asking us for. All right, so just a reminder, I have another example of how you name your exponents down here.
Okay.
So if the degree or exponent, so if there is no variable, right? And there's no exponent, right? We call that a constant, right?
I gotta write that down. Constant.
So if it's no degree or no variable, right? We call it just a constant. If we have just the variable, the exponent is 1, and so that is known as a linear polynomial. It's just linear. When our exponent is 2, that's what we call it a quadratic. When our exponent is 3, we call it a cubic. When it's 4, quartic. And when it's 5, quintic. All right, so those are our names according to degree, right? So if we take that information and kind of go back up to our table, we've already named what kind of polynomial we have here at the back, right? So now if we use the degree, we can add the degree and the name of the polynomial to finalize the actual name, right? So if the degree is 3, right, its name is cubic. So for this first one, the example that I did before we started doing this video, we have a cubic trinomial. So that's how you name this, right? It's called a name by the degree.
Okay.
Kind of polynomial. So it's a cubic, right? Because the degree is 3, trinomial, right? We don't have a special name for 6, right? So we can skip that one. But the degree here is 1. When we have 1, it's called a linear.
I couldn't hear you.
I'm sorry, for 6, we don't have a name. We don't have a special name for 6, right?
Okay.
So we're going to skip 6. Well, when the degree is 1, it's called linear, right?
Right.
So we have a linear binomial. Linear binomial.
Okay.
I'm actually going to just put these words in here. So
Right.
this is a cubic trinomial. This one is a linear binomial, right? This one is also 1, so it's also linear. So it's a linear monomial, okay? When the degree is 0, it's called a constant. So when the degree is 0, it's called a constant. So we have a constant monomial. Right. When a degree is 4, it's called a quartic. I hate that word. Quartic. So we have a quartic polynomial. Quartic polynomial. And then the last one, the degree is 2. When a degree is 2, we call it a quadratic, which is what we're going to be working with next week.